Okay. Well, here's the situation with this radio now. It's working. It appears to be working really well. I'm pretty sure if I put a proper antenna on it, it'll work well on shortwave too. The IF seems to be a little off. The front dial seems to be dead on. That's kind of a curiosity. That kind of minor misalignment could cause some problems with the front end not tracking properly with the local oscillator. Make the radio work really well at one end of the band, not so well at the other, or something like that. Wow. Okay, so now I'm facing the same thing this is what happened. I know now. This is what happened to the last guy. He went ahead and did these capacitors, played the radio, and went, huh, works really good. Just leave it all. And that's where I am now. Should I just leave all this? Just leave it all like that? No, because this is warming up. This guy's too hot. We need to investigate that. Yeah, we could do that right now. To do that, I need to look at the schematic here in the power supply. I can pull out the rectifier tube or pull the speaker plug out. That will remove this from the circuit. That will also cause a problem with, I can't energize the whole B plus in the radio. It's on the other side here. Could do one at a time. If I could figure out, oh, okay, so look, there's a little triangle there and a little square here, and that might be referring to the capacitor here, that two-part metal can capacitor. That might be enough of a hint right there. Where is that capacitor? You know what? Let's turn this thing off before I stick my fingers in it by accident. Where it is, right up here. Oh! Okay, so there's some heat in the capacitor, but for all I know, I mean, there's heat in the IF can. It's just heating from heat coming up from this big hunk of tube down here. So there it is. Oh my gosh, how am I ever going to see up in there? Let's take a look. Now I did turn it off, didn't I? So it should be pretty good. So I'm trying to look. So there's the can. I got the camera zoomed in really close here. And way yeah, up in there. Now, this is a curious little thing here I hadn't really mentioned, but if you come out here and take a look. Oh. Local and distance. It looks like it's set to distance. And way up in there, totally invisible to me. Way up in there. You see a square in that thing somewhere? I don't think it's focused enough. Okay, let's give this a try now. A little bit of a different focus setting. Can we see a square or triangle? Which is probably not even visible at all. Get the light in there. Just a hint, just a peek, just a little peek at a triangle or a square. Right around that red wire there. Now, see, what's happened is it's hidden out of view by the chassis. You can't, so that's not going to help. Okay, so there's another way, possibly. We can quickly figure out so you can pull out the speaker. to do away with the choke coil and the power supply. Now the power supply is in two pieces. That's not the end of the world. I can fire DC up each piece. And this piece, this appears to go way over here to a switch that may not even be on this radio. This has something to do with the FM part of this radio. Is that really the case? So this doesn't go anywhere else? Comes back, back along here. Tuning indicator connector. Okay, so the tuning indicator, is that on a connector? I never noticed that. These things are not usually on a connector. Wires go through a hole. By the way, these wires often are really stiff. Yeah, these are as stiff as can be. Zero bending of these wires. Means that even just removing this may be enough to crack the insulation on these, and then you're into changing them all the way back. Because there is no plug. They're not common to find a plug in here. So why would that come back to a tuning indicator? Tuning indicator must be operated by, I don't know. Okay, so going back to, can I identify this spot here with the square? Well, here's you know what? This could be that gigantic resistor here. This big thing here. 6500. Not sure what that says. R3, R30. It's got two numbers. It's got two R numbers there, so they're not likely to be that long. Thing. This thing could be it. They actually drew it really long there. What's it say on it? It says 2200 and 6500. It says 6500 written right on it. 6500. It's got 10,000 written right in here. So that's 2200. Ah, this is probably 10,000 right there. Okay, so that'd be the guy. One end grounded. So you see one end just doesn't connect to anything. In fact, that's the terminal right there. It's been bent. Whoop. It's been bent over. So that end is grounded. So we want to get on the 10,000, where the 10,000 meets the 2200. That just goes to the plate there. So that would feed B plus. Get on the other side of the 20. Get on the end of the 2200. End of the 2200 right here. So feed high voltage into here with the speaker disconnected. It'll energize high voltage through the radio, and we'll be able to see the leakage current. That's the plan. That's the plan. Holy smokes! This finally got way too hot. That's okay. By my measurement, this is how I measure temperature on metals like this. Okay, so I can hold my hand for a few seconds. 60. Here's my thermometer. I'm all excited to read the temperature. And what did I do with my? Darn it! Perfectly good chance to. Hey, how about this? It's up where it's supposed to be in the rack. Okay. 40. Wow, okay, so my calibration is way off. I would have put that up around, well, maybe 50 anyway, but not 40. Still feels way too hot. So a big hunk of metal here has a lot of heat energy in it now. So the reason we're doing this, hooking up this supply, is because I can read the current going into the radio with this meter. There should be 1 or 2 milliamps, not much more than that. And if it is, then that certainly denotes a problem. So ground to ground. Okay, it's on a little bracket there. And then this goes on to here with this plug out. Take the plug out. I may not even have to take that plug out, you know. But I think I will. Well, that'll keep the voltage I'm going to apply from kind of backing up into the power supply where I really don't want it to go. Okay, what do we got here? Here it is. Put that on. Right there. Hope I got this right now. Nothing really bad can happen if I take it slow. Take it slow, take it easy. So, current, voltage. This voltage isn't the most accurate. That's 100 volts. That's 200 straight up. So we might get up to 200. On this, I would expect this meter to kind of hop a little bit as I advance the voltage, but then relax back to almost zero. It's a little hard to see there for you, isn't I'll just leave that microphone shadow right in the middle here. Okay. I don't have to do that. My microphone is temporarily off to the side because I had that gigantic cabinet up on my bench, but I don't have that cabinet up here anymore. Let me rearrange that microphone properly. There we go. Okay, I think we're all set now. Give the supply a moment. So that this may or may not explain heat in the speaker. And it's just possible that this is actually the way it's supposed to work. It's supposed to get this hot. I kind of doubt it. I kind of doubt it very much. Okay, so we're ready to go. So this is the one that's telling you something's going wrong, and this one tells you where you are in the test. So let's go up. So I expect to see some movement here. Yeah, it's moving. I'm getting up close to 200 volts. Okay, so that's 200 on this meter. And we've got 2 milliamps on here. You know, I don't think that's enough to explain it. And what have I not engaged by doing the test like this? I've got 1/2. So I think I'm feeding power into here. I believe it's following this line up and then going all over the place to all the plates on these tubes and everything else. But what I'm not energizing, since I have this coil out of the circuit now, I'm energizing this capacitor here, but not this one. Well, they're the same capacitor package, so you could kind of think, well, if this one tests good, this one's probably good too. Now, is it really testing good? A couple milliamps at 200 volts. So that would suggest, because the radio actually runs a lot higher, then probably runs up closer to 300. So there's 300 on there. Now we're at, according to this, oh, that's 25. So that's 10 milliamps. 10 milliamps at 300. So that would be 0.3 k volts times 10 milliamps. 0.3 times 10. 3 watts. 3 watts. 3 watts. Can that, and that's not 3 watts dissipating in the speaker here. That's 3 watts dissipating in here. So the 3 watts dissipating in here is drawing current through the coil. But, and you know what else too? Come to think of it. So by energizing at this point in the circuit, I'm finding out the current that's drawn through the coil. So, another positive. Now all these tubes are not operating. So all I'm doing is kind of testing the B plus circuit itself that feeds to all these tubes. Turn all these tubes on and there's a lot more current being drawn from the high voltage supply. Though I can't really explain why this is hot, and I can't really be sure what to do about it. But there's a radio full of these capacitors sitting here. Okay, so something I really haven't checked out carefully, and I should do it now, and that is this resistor that I measured as being hot. And so in looking at the radio here, this resistor is connected to one of the output tube terminals right here. The other end of it is going to the chassis. It looks like it's going to another tube. It's not. It's going to a ground point. So this is from a pin right to the ground, big high wattage resistor. That's saying to me that this has to be the cathode resistor. This is a push-pull radio. So there's 2 tubes in push-pull. Don't be fooled like me. I started thinking it was these 2. It's not. It's actually these 2 that are in push-pull. You can hardly see the other tube back here. This radio's off, by the way. That's why I'm able to stick my fingers in it. So this cathode resistor is doing the job for both push-pull tubes. That's the normal thing. And there should be a bypass capacitor. Now usually it's a fairly large capacity bypass capacitor, something 5 microfarads, even up to, in some radios, 50 microfarads, a really big electrolytic capacitor. So when you look in the radio there is something leaping out at us, and that's this thing. This guy's a little unusual. I got to be cautious now. I've come across in the last couple radios some unusual things. One of which it's sitting right here on my bench somewhere. I completely obliterated a coil in a radio because I didn't pay enough attention to what I was doing. So here we are. So there's that resistor. By the way, I measured the resistance on this. It's 211 ohms. It's supposed to be 200. So this particular resistor is not implicated as being a problem. It's doing its job. There you can see the ground connection at this end quite clearly. Back to this capacitor. I'll take a look at what's got written on it here. Positive. Oh, okay, positive. So this is an electrolytic capacitor. Look at the leads. This is what I noticed. Look at the leads on it. If I can get my camera in there. Isn't that unusual? It's a stranded wire. And the other end is also stranded wire. So there is the connection to ground. And there's the positive connection coming back to this terminal. So this is an electrolytic capacitor, but you wouldn't normally recognize it as such. 25 volts, that's another hint that it's a bypass capacitor. So when we look at the schematic here, so right in the center of the screen are the two things. There's a 200 ohm resistor, R27. I don't know, does that make it any easier? It'll make it easier for me to work the camera here, so I'm going to go back this way. And there's a capacitor there. You know, that looks to me to say 20 microfarads, or maybe 10 microfarads. It's really hard to read. But if we're gonna pull this guy out, we're gonna know, because it's gonna be written on it. I just can't see it. Made in Canada. You know what? I'm gonna replace this because there's just no reason to mess around. Why the last guy left this in here? I don't know. Was he scared by it? He didn't have any electrolytic capacitors. All he had were these blue ones here. Made in Denmark. Denmark. Yeah, nice looking capacitors. Denmark. There's no way this radio was in Denmark. Let's see. Hey, it's bolted in. I can unbolt it and take that right out. Okay. Let's do these things. Very small little nut there. Probably bigger than that. Radio's definitely off. That must be it there. Holy smokes. I'm going to hold this and turn the nut at the same time. Aha! I think I know now how something happened to this radio. I won't do it too. So the wheel here is knocked out of alignment, and when I'm tuning it and you hear that scraping sound, it's banging into the thing up here. How did that get out of there? Somebody stood this radio up this way and leaned it on that thing. Okay, that's my guess. I just love making up these stories here. My finger on the nut. There, the washer. Now I gotta flip this guy over. I don't know if you can hear me squeaking and whining while I'm doing that. Little squeaky sounds coming out of me. Okay. Now, should I try desoldering it or just nip it? Terminals are pretty easily accessible for the replacement here. Sorry about that. Replacement of this. For now, I will cut the wires and leave a little bit there. You know, they're stranded though. They're really. Yeah, I can pull them off with a pair of pliers and my soldering iron if I really want. I want to test this capacitor. 20 microfarads, 25 volts. Okay, let's do that. Let's give them a test here. See what we end up with. Okay, so this is an electrolytic capacitor, so I need to make sure this is switched that way. And red is the positive. We don't want to do this backwards on these guys. What did it say for voltage? 25 volts. Oh my gosh. Well, that's the lowest setting on my machine. 25 volts. So, once again, just to explain this quickly, when I apply the voltage to 25 volts, this eye will start indicating what kind of current is flowing through this capacitor. First, there'll be a charge current. The eye will indicate that by closing. If it stays closed, that means there's a leakage current continuing through the capacitor. There shouldn't be any leakage. A perfectly good capacitor will show no leakage. Electrolytics always have a little bit of leakage, but that's why this switch is here. So it kind of sets this machine up to be calibrated for electrolytic. Otherwise, it would all appear bad. 25 volts, here we go. Watch the eye now. Does it stay closed? Wow, okay, so that popped open so fast. It tells me something is wrong with this test here. Let's try again. Wow, okay, now that's ridiculous. Okay, so there's a 20, we'll make it way more sensitive now and pretend this is not electrolytic. Okay, so on that, see, the eye just stays completely closed. On the electrolytic setting, at 25 volts, it looks like a wondrous capacitor. Okay, so if it is a wondrous capacitor, then we should be able to measure its capacity. So we would set this to 20, let's go 0.1 to 50. Okay, now you watch for the eye. When I turn the dial, the eye will open where the capacitor's capacitance is. Way down here. Wow. When this instrument operates like this, when you have the dial all the way to an extreme, you kind of have to pretend it just didn't happen. Wow. Okay, so 20 on this scale should end with 50. 20 is right in here. I don't see anything happening there, but way down here for some reason. Let's make it pretend we're testing a smaller capacitor here. No, it's not gonna. There's some weird. You can't see this in the camera, but there is some weirdness going on here. But again, I'm up at the end of the run. You know, this one is 20 to 1,000. So let's get down around 20. Would be 20 to 1,000. It's this inside scale. So 20 is right here. I think the situation with this capacitor is it's open inside. The capacitance is not presenting itself at all to this. Nothing. It shows open as if there's no capacitance. That sudden popping open here. So I think we've got an open bypass capacitor. Now the result of that is you're no longer bypassing the cathode resistor, and that means the actual signal you're trying to get to the speaker, instead of going, this isn't really quite the way to say it, but let me say it this way, instead of going around the resistor, it's forced to go through the resistor. Yeah, that's kind of true. So along with the steady state DC current that flows through any tube, the two tubes in this case. Along with that, in this resistor is a signal current too. So I think a faulty bypass capacitor could result in more heat in this resistor. Also, the whole reason you're trying to bypass this resistor is so that it doesn't consume any of the signal. But if your bypass is a dud, like this one appears to be, then some of the signal is being consumed. I mean, it's generating heat, right? It's being consumed in that resistor. And the ultimate effect of that is reduced voltage. Reduced volume. Reduced volume in the speaker. So for sure we got to put a 20 in there. A 20. Hey, let's go ahead and do it. I'm going to dig out a 20 here. I'm going to go with the big guy here, 33. Hey, let's put this on the tester. See if this really. Let's test the tester. And I'm not talking about me. Let's test the tester. Okay. Negative. Positive. And this guy's good to 400 volts. We don't need to go that high. Okay, we're on the electrolytic setting, 25 volts. Check the polarity. Polarity is correct. Watch the eye. Now, that's how it should operate. Let me try that again. Watch it. Yeah. So that you can see the charge go in to the capacitor, and when it's fully charged, current stops, eye opens. Good. Try this at 250 volts. This takes longer to charge, but there it is. Now we're going to let that sit for a bit. This device puts a short on the capacitor when you let go of this spring-loaded control. So we're just letting the charge bleed out of there for sure before we do the next part, which is measuring it. It's supposed to be 33. Let's see, 33 sounds like it's between 0.1 and 50. And 33 would be right up close to here. Okay, so watch the eye. Oh, right there. Okay, and when I read that, 1027. I would read that as 27 on here. Now, let's fool with this a little bit. That's not going to help. This is a power factor adjustment that I've never gained any advantage from. I really don't know. 33 appears in two places in here. I can also get it on this scale. Let's try this one. So there it is there. Barely see it opening. So this scale is 20 to 1,000. 20. How does that work? 20 to 1,000. Oh, it's way inside here. I can't see it. Okay, that's good because the number 20 is right under where this is. No, I don't want it to be 20. I want it to be 33. So 33 is way up here. So what is it? Is it the capacitor? Or is it the test? Let's try another one, identical. I think we're going to find out the calibration on this is not that reliable. Exactly the same kind of capacitor. It's exactly the same reading pretty well. So what I'm finding out is my device here isn't as calibrated as it could be. Right there. So here it's reading very close. 10, 20, 30. It's reading about 25 here. A little different on the other scale. So there's probably capacitors inside here that I really should be replacing and I haven't, etc., etc., etc. Okay. So this goes between a terminal and ground. We want the negative to the ground and the positive right there. The interesting question is, could this affect at all the temperature of the speaker coil? I really think the answer is no to that. So it sure can't hurt. What about the hums and stuff like that? No, I don't think this can really be part of that kind of picture. Lots and lots of solder. There we are. Okay, double check the polarity. Negative is where it should be. Just 1 second here. Okay, let's see if we can find some more bad parts down in here, down in this area. So I think I'm going to leave this resistor since it's very close to what it's supposed to be. These guys all look nice and colored. This guy looks like he's been on a rough journey there. Okay. Not quite as clear in the camera, but so I want to check this. So what I see is one side goes to the chassis, the other side goes to this terminal with 1, 2, 3 resistors and a capacitor hooked up to it. This capacitor is a little bit odd. I wonder if this terminal isn't not used or not connected. So I want to find out what's going on there. Let's see. That's pin number 1, 2, 3, 4, 5. That's pin 6 on the output tube. The output tube is a 6V6. So we go 6V6. Let's look it up. 6V6. So we're looking at pin, did I say 6? And there's the pin out right there. You can kind of see it. Pin 6 is missing. So pin 6 is available as a terminal in the radio. And that's what's going on there. So they've connected together quite a few things. This capacitor is probably the easiest to come off this terminal on this tube. We can probably find this capacitor at the other end will show us where these resistors are. So, okay, after an awful lot of study of the schematic and the radio, I've sorted out this. So these two resistors, 27 megohm resistors, each of these go to the grids of the output tubes. That goes to a grid of an output tube. This radio's not on, by the way, in case you're wondering why I'm sticking my finger in it. And the other side of this resistor also goes to the grid of the other output tube there in push-pull. This guy here, this guy is a real interesting question. He's burned up a bit. The schematic clearly shows this should be a megohm on the schematic. But the colors here are for 100K. That's a black, that's a body end dot, brown, black, yellow. It's 100K. This measures about 110K. So the question is this wrong? And this should be megohm here. So what this is doing is it's just allowing a charge dissipation into the chassis. This is cut, of course, so I could measure it. But this was connected to the chassis down here, and its purpose is to avoid allowing a charge to build up on the grid. Basically, that's what it is. So what happens if it's wrong? So these output tubes get their bias via a cathode resistor. It's supposed to be a 14-volt bias. So what would happen? I think all that would happen is it would just quiet the output. If you made this even smaller, it would just start kind of draining the signal off the grid. Why would it burn up? Is it in any position to burn up? That's a really good question here. So this is really hard to look at, but here's the grids. Here's the 27 megohm resistors, the two of them. And then here, it's really hard to see, is 1 megohm resistor down to the chassis. That's that guy. And into that point with the 3 resistors are connected together is a capacitor. And there it is there. And this terminal on this tube is not a active terminal. That's a spare terminal on the tube, so they've used that as a connection point. So what's that mean exactly? I think what I need to do, because I did measure this a little bit off, is check this bias, check the voltage across this resistor. I should have done that before, as soon as I became suspicious about it. And I need to reconnect this back to do that test. Phooey. Or at least connect this to connect it to ground somehow. Okay, we're all set. The voltmeter is connected across the cathode resistor on the output tubes. So, and we're expecting 14 volts according to my RCA tube manual. So 14 or so. Volume down. I don't have the speaker plugged in. Can't expect anything without that. Always a little hesitant. I made some changes in there, of course. So here we go. Okay, dim lights work fine. So we'll leave it on restricted power just now. I'd better turn it up a bit. $14. Now, we'll flip it up to full power here, and we'll find out what this really goes up to. My imaginations are getting louder and louder. Turn it down a bit. Yeah. Could be getting louder for reasons nothing to do with this. 17, eh? Let me look at the manual again here. 17 is still going. 6V6. It could be I didn't look at the push-pull setup for a 6V6. Let me check that carefully here. 6. Looks like it's stabilizing now, eh? So, looking more closely now. Single tube push-pull class AB amplifier. Grid number 1 voltage should be, okay, it depends on the B+. So if the B+ is low, minus 15. If the B+ is high, minus 19. We're right in the middle there. That's great. So B+, I should measure that and see what it is. That's something else I should have done a while ago, but didn't. That will be visible on pin 3 of either 6V6. Okay, 6V6. Now I'm going to use these clips here. Okay, everybody, put your money down. First of all, what pin did I say? Pick your money back up. 6V6. Pin number 3, I'm sure it was. Pin number 3, yes. That's what I thought. That's what I thought. I have a little bit of Kreskin in me, you know. Okay. There we go. Kreskin. Nothing more than a magician. Okay. Now, let's pick one. Pick a tube. Pick a tube. Bring a tube here. Pin 3 has the blue capacitor coming to it. Leading from it, I guess would be the way. So here we go. Okay, get your money down now. What is the B+? 260. Tell them what they've won. Okay, 260. That would be low. So that would be slightly lower. You know what? That's no problem. There's no problem with the bias. If the bias is a little high, the tube runs a little cooler. So actually that's really quite excellent. That's great. Now, so what to do about this bleeder resistor here? You know, I'm going to leave it as it is now. It could have been some production change that's not reflected on the schematic. Radio works fine. It's hardly a critical resistor. It's pulling down this point to ground. There's no current flowing through it. So something like that's going on. Okay. Now, in the meantime, I've figured out a couple other things here. I better turn this off. Turn her off before. So there's a couple of wax capacitors. One here, one here. Here's this base switch, and yet there's a tone control. This is the tone control up here. The tone control has a capacitor. It's still wax. So lots of wax stuff going on here related to the tone control. So I think what they've really got is a treble cut. The rotating tone control is a treble cut. But this switch one here might in some way boost the bass. I'm not sure. Maybe that's why they've done it quite differently. So you really got a bass and treble. That's kind of really what this is. Although they call it bass and tone. Great. So I think the name of the game, the next step, easy step, continue to finish off the audio part of this radio. Is do those 3 capacitors there, and I think that's a good thing to do next. After that, what's left is the all the radio capacitors up in here, and whatnot. Hey, thanks so much for watching, and I hope you're enjoying this.